Hey everyone, welcome to our exploration of constitutional engineering. You might be thinking, constitutions and engineering, what's the connection? Well, just like a spaceship needs meticulous blueprints, societies need well-designed frameworks to thrive. Today, we'll be your cosmic guides, exploring how scientific and engineering principles can help us design robust, adaptable constitutions. Get ready to see familiar concepts in a whole new light. Let's start with the basics. Mechanics. In physics, force causes motion. In societies, it's legal authority that gets things moving. Think about it. Laws, regulations, and legal institutions exert a kind of force that shapes behavior. Just like gravity keeps us grounded, legal authority provides the framework for a functioning society. Now, imagine trying to build a bridge without understanding gravity. Chaos, right? The same goes for constitutions. Without a solid understanding of the forces at play, the push and pull of rights, responsibilities, and limitations, we risk creating systems prone to collapse. Next up, thermodynamics. We all know heat can generate pressure. Think about a boiling kettle. In the legal realm, regulations and their enforcement generate a kind of legal pressure. Too much pressure, and the system might explode. Think revolutions or widespread civil disobedience. Too little, and things stagnate. Imagine a society with no consequences for wrongdoing. Finding the right temperature, the optimal level of legal pressure, is crucial. This means striking a balance between individual freedoms and societal needs. It's about creating a system where regulations are robust enough to maintain order, yet flexible enough to allow for progress and innovation. Electromagnetism teaches us about the power of attraction and repulsion. Similarly, legal power needs a clear and potent charge to be effective. A constitution must clearly define the sources of authority, the rights it protects, and the mechanisms for enforcement. Without this clarity, you get confusion, ambiguity, and ultimately, a system that fails to command respect. Think of a magnet. Its strength lies in its focused magnetic field. A well-designed legal system is like that. Its power stems from its clarity, consistency, and the certainty of its application. When people understand the charge of the law, its purpose, its reach, and its consequences, they are more likely to comply. Now let's dive into the world of fluid dynamics. Just like viscosity affects how a fluid flows, legal systems encounter resistance to change. This can come from deeply ingrained social norms, traditional beliefs, or even vested interests resistant to reform. Think about it. Trying to implement new laws without considering these societal currents is like trying to swim upstream against a raging river. It's a recipe for frustration and failure. A well-engineered constitution anticipates these points of resistance. It builds in mechanisms for adaptation, evolution, and even conflict resolution, ensuring the legal system can navigate the ever-changing currents of societal values and needs. In materials science, we learn about stress and strain, how materials behave under pressure. A legal system too needs to withstand stress without crumbling. Social, economic, and technological changes constantly test a constitution's limits. Think about the rise of the internet or the demands for social justice. These events put immense pressure on existing legal frameworks. Just as a bridge needs to be strong enough to bear weight, a constitution needs the resilience to withstand these stresses. But it also needs flexibility. A rigid, unyielding system is brittle, prone to breaking under pressure. A well-designed constitution, however, bends without breaking, adapting to new realities while upholding its core principles. Control systems rely on feedback loops to maintain stability and adjust to changing conditions. Similarly, a well-designed legal system incorporates feedback mechanisms to ensure accountability and responsiveness. Think of it like a thermostat. It constantly monitors the temperature and adjusts the heating or cooling to maintain a comfortable environment. In a legal system, public opinion, judicial review, and democratic processes act as these thermostats. public discourse highlights areas where laws might be falling short. Judicial review ensures laws align with constitutional principles. And democratic processes allow for the modification and evolution of laws over time. These feedback loops are crucial for preventing stagnation and ensuring the legal system remains aligned with the needs and values of the people it governs. Now let's venture into the mind-bending world of quantum mechanics. Just as a particle can exist in multiple states until measured, laws can sometimes exist in states of ambiguity until clarified through interpretation or application. This isn't necessarily a flaw. The framers of a constitution can't anticipate every future scenario. They leave room for interpretation, allowing the law to adapt to unforeseen challenges. It's like writing a recipe with some ingredients left open to interpretation. This allows future generations to adjust the recipe, adding their own flavors while staying true to the original dish. This inherent flexibility allows legal systems to remain relevant and responsive to evolving societal needs. Einstein's theory of relativity revolutionized our understanding of space and time. Just as the passage of time can be relative, the relevance and applicability of laws can also change depending on the context. Societies evolve, technologies emerge, and new understandings of the world take hold. A constitution drafted in one era might face challenges unforeseen by its creators. Think of it like using a map from centuries ago to navigate a modern city. While the basic layout might hold, new roads, landmarks, and challenges would require adjustments to our understanding and our route. A successful constitution must balance the need for enduring principles with the capacity for adaptation, ensuring its continued relevance in a constantly changing world. Let's step into the realm of statistics and data science. In these fields, bias and variance are crucial concepts. Bias refers to errors stemming from assumptions in our models, while variance relates to a model's sensitivity to small fluctuations in data. In a legal context, bias can lead to unfair outcomes, where laws are applied unevenly or disproportionately impact certain groups. Variance, on the other hand, might result in unpredictable or inconsistent legal interpretations. Think of it like aiming at a target. Bias is like consistently hitting off-center, while variance is like having your shots scattered all over the place. A well-engineered legal system strives to minimize both bias and variance, ensuring laws are applied fairly, consistently, and predictably across all segments of society. Structural engineers are masters of distributing weight and ensuring stability. Similarly, a well-designed constitution carefully distributes the load of legal responsibilities. This involves dividing powers among different branches of government, executive, legislative, and judicial, preventing any single entity from holding too much sway. Think of it like building a skyscraper. You wouldn't put all the weight on one central pillar, would you? You'd distribute the load across multiple columns, beams, and foundations to ensure stability. Similarly, a well-balanced constitution distributes power, ensuring no single entity can topple the entire structure. This separation of powers, with its checks and balances, is crucial for preventing tyranny and safeguarding individual liberties. In physics, kinematics is the study of motion without considering the forces involved. In a legal context, we can think of it as the study of how laws evolve, change, and interact over time. Just as we can track the trajectory of a projectile, we can analyze the historical development of legal principles, the societal forces that shape them, and the consequences of their implementation. This historical perspective is crucial for understanding the legal DNA of a society. By studying the motion of laws through time, we can identify patterns, anticipate potential pitfalls, and make more informed decisions about future legal developments. Dimensional analysis is all about understanding the fundamental units of measurement: length, mass, time, and how they relate to each other. In crafting a constitution, we also deal with fundamental units, although these are conceptual rather than physical. These might include principles like justice, equality, liberty, and fairness. Just as a physicist needs to ensure their equations are dimensionally consistent, Constitutional architects must ensure these core principles are woven throughout the legal fabric. These fundamental units provide the framework for interpreting laws, resolving disputes, and guiding the evolution of the legal system over time. They act as the constitutional DNA, shaping the character and values of the society governed by those laws. In engineering and computer science, optimization is about finding the best solution within a set of constraints. Legal systems too operate within constraints, limitations on power, resources, and even the very nature of human behavior. A well-designed constitution recognizes these limitations and optimizes for desirable outcomes. Just as an engineer designs a bridge to withstand specific loads, a constitution establishes boundaries to prevent abuses of power and protect individual rights. This requires a deep understanding of systems thinking, recognizing the interconnectedness of different parts of the legal system and how changes in one area can ripple through the entire structure. By approaching constitutional design with an optimization mindset, we can create systems that are not only fair and just, but also efficient and effective. In computer science, latency and throughput are key considerations. Latency refers to the delay between input and output, while throughput measures how much work gets done in a given time frame. These concepts have surprising relevance in the legal realm. A high-latency legal system means justice delayed, which, as the saying goes, is justice denied. Think about court backlogs or lengthy appeals processes. These delays can have real human costs. Throughput, on the other hand, relates to the legal system's capacity to handle cases, enact new laws, and adapt to changing societal needs. A low throughput system can become overwhelmed, leading to bottlenecks and inefficiencies. A well-engineered constitution considers these factors, aiming for a legal system that is both responsive and efficient, delivering timely justice while effectively managing the demands placed upon it. Finally, we arrive at the crucial question of measurement. How do we evaluate the success of a legal system? This is where we consider both quantitative and qualitative metrics. Quantitative metrics might include things like crime rates, case resolution times, or the number of laws passed. These offer objective, measurable indicators of how the system is performing. But we can't ignore the qualitative aspects, things like public trust in the judiciary, perceptions of fairness and equality, and the overall sense of justice felt by the people. A truly successful legal system needs to excel in both areas, demonstrating measurable effectiveness while also upholding the intangible but essential principles of justice and fairness. It's about achieving a balance between the quantifiable and the qualitative, ensuring the legal system serves both the needs and the values of the society it governs. So, there you have it, a glimpse into the fascinating world of constitutional engineering. By viewing legal systems through the lens of science and engineering, we gain a whole new appreciation for the complexities involved in building a just and equitable society. By treating constitutional design as a dynamic engineered system, we can create fail-safe mechanisms, ensure legal adaptability, and optimize societal well-being. It's about recognizing that just as our understanding of the universe is constantly evolving, so too must our legal systems adapt to meet the challenges of a changing world. Stay tuned for more insights into how science and engineering principles can transform our understanding of law and governance.